So as we move into the next example, I think this is question 13. This says factor by grouping. For me, what makes this hard is there's not a GCF in these three terms. So since I don't have a common factor, the coefficient of the quadratic term, this 4, stays in the problem. So what happens is if we have an equation where we have ax squared plus bx plus c, where again, the linear coefficient, I'm sorry, the quadratic coefficient is not 1, it's actually a number, like here. So this 4 becomes our A, if you will. The 21 becomes our B, and our 5 is our C. So notice how the A is called our quadratic term coefficient. The 21 is our linear term coefficient, and the 5 is our constant. So we can also just use these A, B's, and C's for things. So since it says factor by grouping, the strategy first is I like to use the four square strategy. This is my organizer. So this is my grouping way of doing this. So I'm going to draw a rectangle. Make sure you leave yourself some room above and to the side. And then I'm going to partition off into 4 spots. Now, the way the four square method works is the quadratic term goes in the top left. So automatically, the 4r squared is going to go here. And then the constant goes to the bottom right. So the 5 will go on the bottom right. Now, what happens is we have these two spaces left. That's where the linear terms are going to go. So the linear terms, this 21r is going to be broken up into 2 linear terms as opposed to 1. So we're going to break up this 21r. Now, the way we do this, though, is to create these 2 linear terms, we want to multiply the quadratic term coefficient by the constant. In other words, the A times the C. So this is where I'm going to use my little T-chart as well. So not great with organization still. So what we're going to do to create the rest of this problem is we're going to multiply the 4 times the 5 and get this 20. So this 20 is going to go here. Now the catch is this number we're going to use to create the linear term, the coefficients of the linear term, because there's going to be 2 of them here. So what has to happen is that the factor of this number must add equal the linear term coefficient. It must equal the B. So in our problem, the B is actually the 21. So what we're trying to do is figure out what are the factors of a 20 that give me a 21. Well, notice that right off the bat, 1 times 20 is 20, but 1 plus 20 is 21, so we really don't have to go any further. So what we're going to do is we're going to use these 2 numbers as the coefficients of the linear term. So what we're going to do is put a 1r here and a 20r here. So notice how the 21r becomes 2 linear term coefficients. So now we're just going to turn our attention to the box. So from here, when we do factor by grouping, we look for the GCF in the top row. What does a 4r squared and a 1r have in common? Looks like the only thing I'm seeing in common is they have an r in common. So I'll bring out an r. If I look at the 20r plus 5, what do these 2 terms have in common? It looks like they have a 5. Now what I need to do is figure out what was left. And that's going to go up here. So what I do now is ask myself, well, if I took an r out, what did I need to get a 4r squared? Well, what times r is 4r squared? Well, I would need a 4 and an r. 4r times r does give me 4r squared. So if I take an r out, what was left is a 4r, if you will. So again, we're actually dividing it out, but we're using multiplication to kind of verify things. So what times r would give me 1r? Well, since I have 1r, all I need really is a 1. 1 times r is 1r. Now notice this actually completes the rest of the problem because 4r times 5 does fill in this box. 4r times 5 is 20r, and 1 times 5 is 5. So notice how the rest of the problem is complete. So when I use factoring by grouping, I'm using my 4 square as my grouping strategy. So now that we have it all completed, our factors are these outside edges. So what we have then is this r plus 5 times then this 4r plus 1. It becomes our factored expression. So that's how 4 squared can kind of help us do it when the quadratic term's coefficient is not 1. It's another number.